Hi, well, I'm going to talk through the 2022 Key Stage 2 Year 6 Mathematics Paper 2, which is reasoning. And I just want to go through it all, which should be fun. So the blank page, you've got to get used to lots of blank pages. I have no idea why they have blank pages. And instructions, important to read all the instructions. And then we come to question 1. Always read the question very carefully. Circle the greatest number, the biggest number. So those are nice big numbers, aren't they? Love a bank account like that. But let's have a look at the decimal places first. So I'm taking the first one. These are commas, not the thing is, where do you put the decimal point in a number like that? And the rule is for decimal points, if you can't see the decimal point, it's at the end. It's at the end of the number. So the decimal point is here. And you can put decimal point. And you can put zeros after that if you like. You know, you can carry on writing zeros all year if you want, because they're all zeros. There's nothing else after that. So if you just revise your decimal places, that's the units or the ones. That one's the tens. This one is the hundreds. This is where my writing gets really messy. This one is the thousands. It's getting bigger and bigger. These ones, that's 10,000s, 100,000s, and millions. So the commas just separate every 3. So when approaching a question like that, just go to the far left first to start with. They're all got 9 in the millions column, haven't they? They're all 9 million and something. So really, that doesn't help you decide which is biggest or smallest. They're all 9 million. It doesn't really help, does it? So we go to the next one along, which is 100,000s column. We got 2, we got 2, we got 2, we got 2, and we got 2. That doesn't really help either to sort of distinguish them or to sort them. So let's go to the next one. And the 10,000 column, here we got 0, here we got 1, here we got 0, here we got 1, and here we got 0. So at this point, the ones that have got 0 in their 10,000s column, we can get rid of. And when you're, I don't suggest you make so much mess on the page when you're answering this. You'll probably get scrap paper or something, won't you? So now these are the two between these two. And to decide the next one, they're all 9,200,000, and they've got 1 in 10,000 column. They've both got 5 in their thousands column, so that doesn't help either. So, but then we go to the hundreds column. This one's got 2 in the hundreds column. This one's got 3. So this one's the winner. So it is, the answer is 9,215,300. And actually you'd circle it, you see, just circle it, and you wouldn't have all this mess, obviously. Next one. So again, reading very carefully, these are quite short. One table can seat 8 people. It can, can't it? How many tables are needed to seat 40 people? Well, if you're not sure about this, one good thing is draw it. Picture it in your head. And draw extra tables. Imagine it. You've got one table's got 8. How many tables? Let's do another table. I'm not very good at drawing chairs. There's another table. 2 tables. How many chairs would we have? Well, we'd have 8 here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 on the second table, wouldn't we? So 2 tables can sit 2 times 8, which is 16. So you could keep going if you like. 1, 2, 3, 4, 5, 6, 7, 8. Another one. 1, 2, 3, 4, 5, 6, 7, 8. So just, it's your 8 times table, isn't it? 8. Second table, 16. Third table is going to be 24. Fourth table, 32. Fifth table, 40. So the answer is you can have 5 tables because 5 times 8 is 40. I mean, another way to do it is you could do 40 people divided by 8 people gives you the number of tables, which is 5. Because you've got 40 people to seat divided by 8 for each table is 5. Okay. Well, here you have 400,000 plus something plus 70. So this here is a 400,000, obviously, in here, in the answer. There's a 70, you see. There are a lot of zeros there, but this number obviously refers to the one they want, which is in the 10,000s column, so it's 30,000. There you go. Great. Next one. Children estimated the number of beans in a jar. Oh, yeah, I had to do that when I was a kid, I remember. I failed miserably. These were the estimates of 5 children. Okay. The exact number in beans in a jar was 1,380. Whose estimate was closest to the exact number? Well, with this one way to do this is to look at how far they are away. So let's have a look. Amir, he guessed 1,310. Well, we could probably do that in our head. So how many was he away? He was, the exact number was 1,380. So he was 10, 1,310, 20, 30, 40, 50, 60, 70, 80. He was 70 away, wasn't he? And then Olivia, 1,220. Well, she's below, obviously her estimate's an underestimate, but let's see how far she was. We could do 1,220 plus 1,000 would give us 1,320, wouldn't it? And then we can count up to 1,380 again, 20, 30, 40, 50, 60, 70, 80. That's 100. Oh, I'd say 1,000. I'm going mad. 100, thank you. So that's going to be 20, 30, 40, 50, 60, 70, 80. That's 160 away, isn't it? Unless I'm going mad, 160, I think. Yeah. I think that's right, isn't it? I'm not going mad. Okay, next one, 1,400. Well, we can count down then, can't we? 1,400 is 20 away. So Emma's looking pretty close. 1,290. Well, if you add 1,290 plus 100, that's going to be 1,390, isn't it? But they want, it's 1,380, so it's 10 less than 100. So she's 90 away. You could do sums if you like. And then Chen, well, he's 80 away, isn't he? Because he's 1,380 plus 100 is going to be 1,480, isn't it? But then he's 1,600, so it's 80 away. You see? And don't be scared to use your fingers to count. Some people say, oh, you should use your fingers, should use your fingers. I mean, in every exam, every test, hopefully you'll have your fingers, won't you? So why not? You know, there's no reason. It's quite good. I sometimes count with my fingers. Anyway, whose estimate was closest to the exact number? It was Emma, wasn't it? Whose estimate was furthest from the exact number? bless her, it was Olivia. She was way off. So you might find you can do these in your head, which is great. You're just going to look at them and you'll just work them out in your head. Fabs. And the more you do, the better you'll get. 1 ton is 1,000 kilograms. A truck can carry a load of 2.3 tons. How many kilograms can the truck carry? Well, it's 1,000 kg, isn't it? Kilograms, because that's 1 ton times 2.3. And that's going to be 2,300. How could we do that? Well, you could do it the other way. You could say you've got 2.3 times 1,000. What happens to the decimal point when you multiply by 1,000? It hops. There are 3 zeros in 1,000, so it makes 3 hops. 1, 2, 3. I'll do a separate video on all these things. And then the zeros fall into these little loops like marbles, you see? And then you've got the answer. Take away the decimal point. 2,300. Great. So, yeah. When you multiply by 10, 100, 1,000, or divide by 10, 100, 1,000, the decimal point can just go hop, hop. Emma has 5-litre bag of compost. Good for her. She uses 2.75 litres. How much compost does Emma have left? Well, we've got to take the 5 litres, and here it's important. Where is the decimal point in 5? Can we see a decimal point? No, we can't. So it comes at the end, which is there. 2.75, where's the decimal point there? Well, it's obvious where it is because they've written it. So we do 5 minus 2.75. And don't be scared of decimals. You do them just like any other sum, but just remember to put your decimal point there, that's all. 0 minus 5, we can't do that in these sums. So the 0 goes to that 0 and says, or you can have one from you, and that 0 says, I haven't got any either. So they go begging to the 5, which says, all right, and gives 1 the 10ths column. That becomes a 4. Now that's got its 10. It can give 1 to the units column, which becomes a 10. 10 minus 5 is 5. 9 minus 7 is 2. 4 minus 2 is 2. 2.25 litres left. So you can do that in your head if you want. But you can do this sum. So just remember that decimal point comes at the end if you can't see it. And you do adding and subtracting just the same as you would without the decimal point. Just adding and subtracting. Okay, here we are. Next one, and always read very carefully. In a race, Ali completes a swim, a run, and a bicycle ride. I'm going to write those down. A swim, a run, and a bicycle ride. The swim is 1/10 of the total distance. Okie dokie. The run is 3/10 of the total distance. What fraction of the total distance is a bicycle ride? Well, in terms of tenths, what will the whole race be in tenths? Is the important bit of this question. What will the whole race be in tenths? It will be 10/10. Because the whole of anything. Now, can I do tenths as the question? 4, 5, 6, 7, 8. Oh, not bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all right, isn't it? Yeah. Okay. So that's 10/10 in a whole. If this were thirds, it would be 3/3. If it was hundreds, it'd be 100 hundredths. You've got the same number on the top and the bottom, so 10/10. So we know that 1/10 of the total distance is a swim. If we do little dotties. Oh no, let's do little waves for the swim because then it was like the water, isn't it? There we are. Swim is 1/10. The run is 3/10. So I'm going to put an R there. R. What fraction of the total distance is the bicycle ride? Well, there's actually only Yeah, bicycle ride. B, 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 B. How many tenths is that? It's 1, 2, 3, 4, 5, 6 tenths, isn't it? Or actually, I know. Let's be clever. It's 6 tenths. We can simplify that, can't we? To an equivalent fraction. And to make them smaller, to simplify, we divide by, they're both even numbers, 6 and 10. So why not just divide by 2? Divide by 2, divided by 2, 3/5. Okay, good. What's the time? No, we're not doing too badly. Okay, circle the improper fraction that is equivalent to 2 and 3/8. Well, 2 and 3/8. If you're converting, so you've got all these improper fractions. The problem at the moment is you can't really compare it because this is a mixed number, isn't it? It's not an improper fraction. Mixed fraction. Mixed number. So what we have to do is turn that into a improper fraction. And to do that, we get the denominator 8, we times it by the 2, and we add the 3. You can convert any mixed number into an improper fraction like this. On the bottom goes 8. 8 times 2, 16. 17, 18, 19, plus 3 is 19. You can do any mixed number like that. So it's that one, isn't it? Lovely. Next. Ooh, this looks interesting. Again, read very carefully. This pictogram, case pictogram, shows how many DVDs a shop sells in 1 week. I thought DVDs were out of fashion now with Netflix and everything, but there we go. On a Monday, 24 DVDs were sold. So that's 24, is it? Ah. How many DVDs were sold on Friday? Well, in a pictogram, the picture represents a certain number of DVDs. In this case, 3 DVDs is 24. 3 times something is 24. So what is 1 DVD going to be? It's going to be 8. Because 8 and 8 and 8 is 24. So you can put a key up here if you want. DVD equals 8. And then we can go to the Friday and we can work it out because there are how many? There's 1, 2, 3, 4, 5, 6 DVDs. Okay, so 6 DVDs is going to be 6 times 8, which is 48 DVDs. But then there's half a DVD as well. So if 1 DVD is 8, what's half a DVD? Well, it could be 4, isn't it? It's going to be 4. So in total, we got 48 plus 4, which is 52 DVDs. And as I say, in an exam, you wouldn't scribble everywhere like I'm doing. Why am I writing that there? I'm going mad. 52. Trying to write and think at the same time. 52 DVDs. There we are. Good. Next. Wheato Teas. What an awful name. A shop has an offer. Wheato Teas. Buy 1 box for £1.90. Get the second box half price. So Ali buys 2 boxes of cereal. How much must he pay altogether? Well, I'm going to put these into pence. I prefer pence. That's 190 pence, isn't it? So for the first box, he's going to pay 190 pence, isn't he? For the second box is half price. So what do we have to do to the 190? We have to chop it in half. Half of 190. So a good way to do that is via bus stop method. I use the bus stop division method. So 190 divided by 2. The 190 goes underneath the bus stop. 2, how many 2 goes into 1? 0. So it goes there. How many 2s can fit into 19? Well, 9 2s can, can't they? 9 2s are 18. 1 left over. How many 2s can fit into 10? 5. So the second box, he will get, it is a he, isn't it? Ali, yes, that's the male name. 190. The second box will be 90p. So then we can do, you might do it in your head, I don't know. But if not, you can do a bit of an arithmetic. 190 plus 90 is 0. 9 plus 9 is 18. 8 carry the 1. £2.80. 280 pence. But there are 100 pence equals £1. So you do 280. Oh, God, my writing's deteriorating. Divided by 100 equals £2. There, £2.80. You see, it's a decimal points there, and it goes hoppity hop back. Anyway, good. Next 11. Write the missing values. This is equivalent fractions. So what we see is, you see, with equivalent fractions, you can times and divide the bottom or the top by whatever you want, as long as you do the same to the top and the bottom. So here, what do we multiply? Obviously, 20 is bigger than 10, so we're multiplying. What do we multiply by 2? We do the same to the top by 2. 3 times 2 is 6. You see? So now the bottom one, we're going from 12 to 4. It's getting smaller now, so that's going to be divide, isn't it? I haven't left myself enough room. What do we divide 12 by to get to 4? By 3. If you're not sure, do 12. No, actually, I'm sure we'll do that separately. Okay, so that means 15 divided by 3 as well. And 15 divided by 3 is 5. Done. So you can divide and multiply by whatever you want. William has 4 parcels. 1.4 kilograms, 1,500 grams, 2 kilograms, 300 grams. Write the masses in order, starting with the heaviest. What's the problem here? The problem is they're different units, aren't they? Some are in kilograms and some are in grams. So we have to convert them. So 1,000 grams equals 1 kilogram, doesn't it? So to convert 1.4 kilograms into grams, you can have a lot of grams, aren't you, in 1.4 kilograms? So you multiply by 1,000. 1.4 times 1,000 is 1,400 grams. If you're not sure how to do that, take the 1.4 times 1,000. You see, where's the decimal point in 1.4? It is there, isn't it? 3 zeros in 1,000, so it goes hoppity hoppity hop. Zeros come in there, decimal point at the end, and you're sorted. 1,400 grams. That's already in grams. 2 kilograms. Well, if 1,000 grams is a kilogram, 2 kilograms would be 2,000 grams, you see. So we've got to start with, be careful to start with the heaviest. Heaviest is going to be, which one would it be? It will be 2 kilograms, won't it? And be careful to write it in the original way they did it. Done. Next heaviest will be 1,500 grams. Done. Next heaviest will be 1.4 kilograms. Done. The lightest will be 300 grams. Done. Great. Next. Look at the graph below that shows Dev's bike ride. Match each part of Dev's journey to the correct sentence. So just look very carefully when you see graphs. Distance in kilometers. You see, that's how far. Is it a she? I think Dev is a female name, so I'll call her she. Has gone. And time in minutes. You see. So let's look at A and B first, shall we? A to B. Well, on the graph, that's A. She's going there. So what's she done? You can see she's traveled 3 kilometers, hasn't she? In 10 minutes. So which one will be here? 3 kilometers. I can see it now. There we go. Ping mark. BC. B to C. What do you think she's doing there? Her distance hasn't changed. It stays at 3 kilometers. So she is going to be resting for 10 minutes. Then C to D. What's she doing C to D? Well, she's moving again, isn't she? And she's gone 1 kilometer, isn't it? 3 to 4. So she's gone 1 kilometer in 20 to 30 in 10 minutes. 1 kilometer in 10 minutes. Ooh, that one, isn't it? So the last one, we don't even have to look at it. It must be that one. You can check if you want. D to E. Dev cycles less than 1 kilometer in 10 minutes. Fine. Good. Great. Well done. Squash. This 850ml bottle of squash makes 17 drinks. How many milliliters of squash are in each drink? Well, I think it's always good to imagine. So you've got 850 and you've got to make 17 drinks. Just imagine 17 cups. I'm not going to draw 17 cups, but just imagine 17 cups. So your 850 has to be divided into 17 cups, doesn't it? It has to be divided. So something you could do here is you could do 850 divided by 17. So I would do a division like this. 850 divided by 17. Here, I think we might have to have a bit of a 17 times table going. Because it's two numbers, isn't it? Unless you happen to know your 17 times table in your head. I don't, I'm afraid. And I do it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17 up there. Times this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, the first one's obviously going to be 17, isn't it? And then what's 10 times 17? Well, 170. If you add a 0, we'll move the decimal point. And then we just get the second one. Just do a little adding if you want. 7 plus 7 is 14. 1, 2, 3, 34. You know, just get a few 17s going. And then 34, add another 17 plus 7, 8, 9, 10, 11, 1, 3, 4, 5. Wait a minute, 7, 8, 9, 10, 11, 1, 1, 3, 4, 5. Yeah, we're doing right. Good. And then I think you could do it like this. So then 51 add 17. 8, 6, 68, isn't it? Yes, good. And then, well, for the 5, you could halve 170. I'm just doing like this. 68, 17. 8 plus 7 is 15. Isn't it? Yeah, 6, 7, 8. 85. Oh, I remember 85. It was here, wasn't it? Okay, so 17 doesn't fit into 8. So 85. It goes in 5 times. Oh, so each one will be 50 mils. And actually, you could do it like this. If you know your 50 times table, which is not too difficult, it's a bit like a 5 times table. You could think of 50, 100, 150, 200, 250. And if you go up to 800, you'll get to 16. 16 times 50 is 800. So an extra one will be 17. So you could think of your 50 times table as well. Which is like the 5 times table, really. Wonderful. 15. Right. Oh, right. You have to have done that. Write the correct sign equals greater than, less than in each box. Remember with the greater than and less than signs, the sign is like a crocodile. Imagine it as a little crocodile. And if you were a crocodile, you'd want to eat a bigger number, wouldn't you? If you had 7, the option of 7 or 1, you go for the 7 because there's more there. So that's the crocodile always wants to eat the bigger number. So it always points to the bigger number you see. Here we have 1 plus 2 plus 3. So we've got to put something in there, haven't we? So I'd work out each side. 1 plus 2 plus 3 is 3, 4, 5, 6, isn't it? And 3 times 2 times 1. Well, 3 times 2 is 6, isn't it? 6 times 1. Anything times 1 is just 6. So here we'll go an equal sign. 2 plus 2 plus 2 is going to be 6 again. But 2 times 2 times 2, well, 2 times 2 is 4, times 2 is 8. So Mr. Crocodile wants to eat the 8. There we have 1 plus 10 plus 10. Well, 10 plus 10 is 20. Add 1, 21. Here we have 10 times 10 is 100. Times 1 plus 100. Ooh, Mr. Crocodile's definitely going to want to eat that. Here we have 0 plus 10 plus 10 is 20. 10 times 10 is 100, but it's times 0. So anything times 0 is 0. Anything times 1 is itself. Anything times 0 is 0. So Mr. Crocodile is definitely going to want the 20 and not the 0. There you go. Done. Next. Tick the numbers. 16. Tick the numbers that round to 28.7. Okay. With rounding, I like to say, this is my saying, well, 5 or above, give it a shove. 4 or below, do the bro. All that follow are 0. You know, so let's just apply that, shall we? I'll probably do a separate video on that at some point. So what does this one round to? Well, this is rounding to whole numbers, aren't they? So 8. Well, 8 is the number we're rounding. We're rounding the ones column. And to decide, it goes to the 0. It's got to go to the number after. Here, the number after is 0. So that's saying 4 or below, sturdy bro. It's going to be 28. All that follow are 0. So we could put 0, 0, but who cares? The second one, we're rounding the 8. The 8 looks to the 6 this time. The 6 follows. And the 6, 5 or above, give it a shove. So the 28 is going to go up to, the 8 is going to be shoved up to 9. All that follow are 0. In this case, the 8 followed by 7. 7's above 5. So it's going to get a shovies. 29. Again, 28.7. 7's going to shove. So it's going to be 29. Oh, 28.9. That's definitely 29. So the only one that rounds, rounds to 28.7. Right, I've got this completely wrong, and I'm not going to do the video again because I haven't got time. So what I'm going to do is, that's if you're rounding to whole numbers. But I was just testing. What I see is 28.7. So it's rounding to the 10th column. So let's do it all again, having practiced that to the 10th column. Here it's 0. That's going to round to 28.1 because it's followed, the 0 is followed by a 7. This one is 6. It's followed by a 5. So the 5 is going to say round up. There's going to be 28 point. That is going to be 28.7. So we can take that. This one, 28.7. Well, we're rounding the 7. It's followed by a 1. The 1 will say, stay there, bro, because it's below 4. So that's going to be 28.7. So we can take that. 28.75. Well, we're rounding the 7. It's followed by a 5. And the 5 says 5 or above, give it a shove. That's going to round to 28.8, isn't it? And this one, well, this is going to round to 29 because the 9 goes up to 10. So that's great. So read the question very carefully, which I didn't do. See, even wonderful, wonderful people like me occasionally make mistakes. 28.7. We're rounding. The 7 is the one that's rounded. 10th column we're rounding. It's got to look to the 100th column to decide. But I think I'll do a video at rounding at some point. 17. 6 divides into 40 with a remainder of 4. It does, doesn't it? Write one other number that divides into 40 with a remainder of 4. Well, if it divides into 40 with a remainder of 4, I'm going to switch my phone off. Then it's going to be 36, isn't it? So I think, write one other number that divides into 40 with a remainder of 4. 9? Let's see. 40 divided by 9. 40 goes under there. 9 goes outside. 9 into 4, 0. 9 into 40 go 4. It's 4 9s are 36. And then remainder 4. So it's 9. So I think with that one, you think if 6 divides into 40 with a remainder of 4, the remainder of 4 means the result's 36. So other things that multiply to give 36, 9. Lovely, next one. Oh, this looks a bit more complicated, but we like that. This sign shows the number of empty spaces on each level of a car park at 10 a.m. Empty spaces. I'm going to underline empty spaces. Parking. Level 2, 511. Level 1, 5268. In this car park, each level has 800 spaces. What is the total number of cars parked in a car park at 10 a.m.? Well, that's quite a big question, so I think we need to read it again. Don't you know? If you ever get to a question you're not sure, read it again. This and take each bit in bite-sized portions. This sign shows the number of empty spaces. They put that in bold, so that's important. On each level of car park at 10 a.m. Each level has 800 spaces. What is the total number of cars parked in the car park at 8 a.m.? Each level has 8. So here, level 2 has 511 empty spaces. So the spaces which you have cars must be 800 minus 511. I'm going to space my numbers out a bit more there. Some people squish their numbers up. Why not? I think we should spread out numbers. Why not? There's no law against spreading out your numbers. 511. There we go. So 0 minus 1 can't do. Goes to 0. Please, please, please. No, sorry, I'm 0. Goes to the 8. Goes to 10. That gives 1 to there. Aren't they lovely, these numbers? That's 9. That's 8. That's 2. 289. So level 2 is 289 spare spaces. Let's do the same thing for level 1. We get 800 minus 268. 0, no. 8 is the only one that has the power to be lovely and give to those. So that's 10 minus 8 is 2. 9 minus 6 is going to be 3, isn't it? 7 minus 2 is 5. So level 1, 5, 3, 2. So the total number of spaces cars parked is going to be 289 plus 5, 3, 2, unless I'm going mad, which is possible. 9, 10, 11, 1 carry the 1, 8, 9, 10, 11, 12, 8, 9, 10, 11, 12, yeah, 2 carry the 1, 5, 6, 7, 8. 8, 2, 1, I do believe. If I'm wrong, let me know, but I think that's right. Okie dokie. Oh my gosh, it's getting exciting now. 19. The circumference of this circle is 60 centimeters. Fair enough. Good. That's all right. It's allowed to have a circumference of 60 centimeters. So you have to know circles. You have to know for key stage 3 things. You have to know the circumference. Now imagine you had a piece of string and you tied it in a circle like that. The tiny little circle. They see. And then you stretch out your piece of string and you measure how long it is with a ruler. That is the circumference. That's how long the distance all the way around. It's like the perimeter of a circle, you see. So you have to know that. That's the circumference. There's a middle of a circle. If you go to the very middle of the circle, and then you go to the edge, a bit like a spoke of a bicycle, going from the middle of a bicycle to the edge, that's called a radius. You see? And then if you go from one side of the circle to the other through the middle, that's called the diameter. You have to know those things. And around the outside is the circumference. So we know what the circumference is. What is the distance around the edge of the circle from A to B? How am I supposed to know that? I don't know that. But there are always clues, and we have to look for the little clues, don't we? And the clue is, what fraction of the circle is this? Well, here we have 90 degrees, don't we? How many 90 degrees are in a full circle? Well, if you imagine a circle, that's 0 degrees, that's 90 degrees. Then 180 degrees is a straight line, isn't it? That's 90 degrees. And then 270 degrees. So 90 degrees is quarter of a whole circle. So if the circumference all the way around the whole thing is 60, if we do 60 divided by 90, I'm going mad. Not by 90, by 4, senior moment. Chop it into quarters, we will have, we could do that in our heads, can't we? 60 divided by 2 is 30. 30 divided by 2, 15 centimeters, isn't it? 15, you see? That's 15 centimeters. Good. Yeah, lovely. Okay. How many more of these are there? Okay. There are 432 places at a dance school. There are 2 age groups. Are there 2 age groups? Lovely. This table shows the number of classes and the number of pupils in each class for each age group at the moment. Now, you study this very carefully. See, age 7 to 12, 13 to 18. Number of classes 15, 10, 16, 18. How many more pupils can join the dance school? What's a good way of doing this? Well, if you're unsure, you might be unsure having read this because it's quite a long thing. Have a reread. Read again. There are 432 places at a dance school. There are 2 age groups. This table shows the number of classes, the number of pupils in each class for each age group at the moment. Well, in that case, I think, do you know what I think we have to do? We have to work out how many pupils there are there already. Then we can see if we can add any more. So for the 7 to 12-year-olds, I'm going to scribble over here. Obviously, you do it nice and neatly in the box. 7 to 12-year-olds, there are 15 classes and 16 pupils in each class. So we have to do 15 times 16. And we do long multiplication times. So with long multiplication, we start with the 6. The unit 6 times 5 is 30. The unit always stays, and we carry the 3. 6 times 1 is 6, add 3 is 9. At this point, what do we do in long multiplication? Splash, plonk, drop an egg. The 6 is now out of action. We can put a slash through there. It's had its attention. Now it's the 1's turn. 1 times 5 is 5. 1 times 1 is 1. 0, 9, 10, 11, 12, 13, 14, 4, 1. 240 children in the 7 to 12 group, isn't it? Yes. Okay, good. So that's 7 to 12 are 240. Obviously, you do that nicely. Pupils. For the next one, we multiply 10 by 18. To be honest, I don't think we have to do long multiplication there. Let's make life easy. 18 times 10 is going to be 180. So, yeah, 13 to 18 is 180 pupils. And you have lovely, neat writing. Don't write like me because it's awful. Because I'm on a computer system, so it's more difficult. My excuse. So then you add them together. 240. We have 240 in 7 to 12. 180. Add them together. 0 plus 0. 8 plus 4. 12. 420 students we got. We got 420. So how many can we add? You could probably do this in your head. 12. Because 420 plus 12 is 432. But, you know, do a sum if you want. Doesn't hurt. 432 minus 420. 2, 1, 0, 12. Lovely. Okay, next. 21. Ooh, shape. Shapes. We like the shapes. Triangles and circles. Each shape stands for a number. The total of the shapes on a diagonal is 48. The diagonal is here, isn't it? That's 48. So yeah, okay. The total of all the shapes is 200. So we've got to work out a triangle. Okay, so the diagonal has 3 triangles. So 3 triangles is 48, isn't it? So we already know divide by 48 by 3 is 1 triangle, which is 16. You see? Good. You see that? Good. So now to find the whole thing, well, we got 1, 2, 3, 4, 5 triangles. So what we have to do is we have to do 16. Now we know what a triangle is. Find all the triangles. All the triangles will be 16 times 5. And you could do a little multiplication if you want. 80. Yeah, 80. So the triangles are 80, but the total is 200. So we've got, in order to get 1, 2, 3, 4 circles, we have to take away the 80. So we have to do 200 minus 80. Which will give us 120. So then 120, let's do it over here, like scribbling. 4 circles. I would do that because it looks like a number. 4 circles is 120, isn't it? So we do 120 divided by 4 will give us 1 circle. 30. Yeah, that's right, isn't it? You can do that in your head, probably. Well done. Okay, great. So that's good. Are we nearly there? How many more of these questions do we have? Okay, because I've got to teach someone. Okay, 22. You can make green paint by mixing 250 mils of blue paint, 1,150 mils of yellow paint. Stefan wants to make some of this green paint, bless him. Okay, so he uses 750 mils of blue paint. How much green paint does he make? That's interesting. Okay. So he's got 250 mils of blue paint and one. So rereading is always good, isn't it? You can make green paint by mixing this and this. What do we have to multiply 250 by to get 750? And the answer is 3. 25 times 3 is 75. 250 times 3 is 750. That's his blue paint. So if he does that, he's also going to have to multiply his 1,150 mils of yellow paint by 3 as well. So he's got to multiply them all by the same amount. So he has the same proportions for his green paint. Okay, so 1,150 times 3. 3 times 0, 0. 3 times 5, 15, carry the 1. 3 times 1, 3, 4. 3 times 1, 3. 3,450 mils of yellow paint. You've got to write everything there. Because I'm going through it, I can't kind of write everything so neatly. So 1,150 times, yeah. Good, yeah. So then you add them together. 0, 0, 1, 7, 8, 9, 10, 11, 12, 2. And then 3, 3,200 mils. Not very neatly written, but there we go. So yeah, so that's how you do it, you see. And then that times 3 times 3. 3, 4, 5, 0. Okay, Adam has a bag of fruit that weighs 1.25 kilograms. He takes out a banana. Now the bag of fruit weighs 1.1 kilogram. Now I'm already thinking in my little noodle how much a banana weighs. Next, he takes out an orange. Now the bag weighs 920 grams. How much does the orange weigh? How much more does the orange weigh than the banana? Well, to find the weight of the banana, we do 1.25 minus, oh yeah, it all weighs one. So even I've got to reread it. You know, Adam has a bag of fruit that weighs 1.25. Once he's taken the banana out, 1.1. So 1.1. Now we do take away, don't we? 5. 2 take away 1 is 1. His banana weighs 0.15 kg. You know, or 150 kilograms. 0.15 kg, which is 150 kilograms. Okay, now when he takes out an orange, the bag weighs 920 grams. Well, in that case, before he took the orange, after he'd taken the banana, it weighed 1.1. Multiply that by 1,000 to get the grams. You see? And he's taken out his orange. So it's 928 minus 0. What am I doing? I'm going insane. Yeah, that's 0, so you can't do that. No, I'm not going insane. I'm not going insane at all. Good. 8 and then 0. Can't do that. 0, 1. 180 grams, isn't it? So his orange weighs 180 grams. So how much more does the orange weigh than the banana? So how much more is 180 than 150 is 30 grams, isn't it? You could do it. Do a subtraction if you need to. How many more of these? Oh, we're nearly there. Yoo-hoo! Okay, here is an isosceles triangle inside a rectangle. Now, what do you know about isosceles triangles? Well, you should know that an isosceles triangle has 2 sides that are the same and 2 angles that are the same. We'll call them x and x, shall we? But the other one's different. So this is an isosceles triangle inside a rectangle. Calculate the sizes of angles x and y. We are told that this is 30 degrees. Because this is an isosceles triangle, we know that this is equal to this, and I'm putting that line across to show those 2 sides are equal. If this is x, because it's an isosceles triangle, this must also be x. Because in an isosceles triangle, we said 2 sides are the same and these 2 angles are the same. So you have to know that all angles, can't spell, in a triangle equal 180 degrees, don't they? I'm sure you know that. All angles in a triangle equal 180 degrees. So what we have to do first is we take away the 30. We do 180 minus 30, which will give us, yeah. Am I going mad now? Oh, no, 150. That's good. 678. So it's 150 degrees is going to be the 2 x's because we've taken away the 30. Then we've got to divide 150 by 2 to get x. 0, 1, 7, 1, 0, 5. 75 degrees, of course. So x is 75 degrees. You see? Using the fact that all angles in a triangle equal 180 degrees, and in an isosceles triangle, the 2 angles and the 2 sides are the same. Now, This is a rectangle. So what do all the angles in a rectangle equal? 90 degrees. Yeah. So that equals 90 degrees. We know already that x is 75 degrees. So y then must be 15 degrees, because 75 plus 15 has to equal 90 degrees. You see? Because it's a right angle in a rectangle. The last one, woohoo. Okay, 25. The triangle is to be transformed on the grid as follows. First, translate the shape 7 units down. Now, when they say translate, it's not like languages or anything. It's a posh word for move. You know, mathematicians, they can't just say move because it doesn't sound complicated enough. So they've got to call it translate is move. They need to be translated. So first, translate the shape 7 units down. Let's do that. Now, let's pick a corner, your favorite corner. What's your favorite corner? My favorite corner is there. 7 units down. 1, 2, 3, 4, 5, 6, 7. Down to there, you see. And just be careful when you count that the first, you start on 0, you see. So the first one is 1, 2, 3, 4, 5, 6, 7. Some people do 1 where they are. They must do that as 0. You haven't gone anywhere yet, so it's 0. So there we are. You can do it to the other ones. Ooh, 1, 2, 3, 4, 5, 6, 7. That's a special shape moving voice. And then here, 1, 2, 3, 4, 5, 6, 7. There. Okay, so now you've got your new shape. We've done what they wanted, 7 units down. There we are. We've translated. Now reflect the resulting triangle in the y-axis. Well, this is your y-axis, isn't it? So we have to reflect it. Imagine it's a mirror. So point there. Well, it's 1 square to the mirror. So we write the reflection 1 square beyond. That's 1 square there. This one is 1, 2, 3, 4, 5 squares for mirror. 1, 2, 3, 4, 5 squares there, you see. And there we have it, the reflected shape. I think we'll get our marks, won't we? 2 marks, ping, ping. I think so. And that is the end. Great. Well, I hope that's been useful. And great. Have a lovely day. Bye-bye.